So at node 2, what do we have? We have this current leaving. So and this node right here is just V0, right? It's the same exact voltage as the voltage across this resistor. So the voltage at the node is just V0. So the first current we have is V0 minus Vn. We're just going to assume everything's leaving again. So V0 minus Vn over 200K plus this next current, we have V0 minus 0 over 20K. So V0 minus 0 is just V0 over 20K. And our last current is just going to be V0 minus this voltage source VA divided by RO. So we have V0 minus VA over RO, which we set up here was 8 kilo ohms, so 8K. And all of this is going to be equal to 0. So I'm just going to go ahead and start a new page. Okay, so the last equation we had from node 2 was just V0 over 20K plus V0 minus Vn over 200K plus V0 minus VA over 8K is equal to 0. I'm just rewriting the last equation that we had written down. So to simplify this, let's just sum up all of our V0. So we have 1 over 20K plus 1 over 200K plus 1 over 8K, all times V0. And then we have a negative Vn over 200K and a negative Va over 8K. And also, I guess we should just do this now. We said Va before was just equal to 50,000 or 50 times 10 to the third, which was our A value, times Vp minus Vn. So we can just make that substitution now. So let's just say this is equal to Vn over 200K plus 50,000 or 50 times 10 to the third over 8K times Vp minus Vn. So if we were to simplify this further now, we have to find out what Vp is, because we can actually get Vp in terms of Vn and Vg. So I'm just going to go ahead and paste that picture that we had before in here. So I just went ahead and pasted the picture that we had in the last page. And as you can see, here's Vp right here. So in order to get Vp in terms of Vn and Vg, this is just like a really, really simple voltage divider. So let's just do this like right down here. So the total voltage, or the Vp essentially is just let's just say the voltage across this 240 volt resistor. So the voltage across that is just Vp minus Vg, which is just equal to, this really, really simple like wire right here. We can just say that this voltage is just equal to Vn minus Vg, which is the total voltage from this Vn node to this Vg source, times, and then this is just like the voltage divider rule. It's just going to be 240, the resistor of interest, divided by 240 plus Ri. So we have 240K over 240K plus, and Ri was equal to 560K. So that's just going to be 240K over 800K Vn minus Vg. And we'll just say that we'll move this Vg over to the other side, so we'll say that Vp is equal to all of this plus Vg. And if you were to simplify this, really simple algebra, you would find that Vp is just equal to 0.7 Vg plus 0.3 Vn. And this is the equation we have for Vp. Well, that's great. Now we can actually make a substitution into this equation we have here for Vp, which is right here. So now we can say that all of this, and if you were to simplify this, all of this would just simplify down to 1.8 times 10 to the negative fourth V0, and that would just be equal to, and 50 times 10 to the third over 8,000 is just equal to 6.25. So 6.25 times Vp, which is, now we have an equation for it, so 0.7 Vg plus 0.3 Vn minus the Vn that's right here, minus Vn. And we also have this plus, I'm just going to write it down here, plus 1 over 200k Vn as well. So now if we were to simplify this, we would find that, well, I mean, we can actually just combine this. 0.3 Vn and negative Vn is just negative 0.7 Vn. So we would have this 1.8 times 10 to the negative fourth V naught is equal to negative 4.375. If we were to just to distribute Vg, so that should be positive 4.375 minus 4.375 Vn plus 1 over 200k Vn, which is just equal to, well, now actually if we were to, it would be easier just to multiply by everything by 200k. So you would find that this would just be equal to 36 V naught. So all of this times 200k is just 36, is equal to 4.375 times 200k would just be 8.75 times 10 to the fifth Vg. And then we have minus 874,999 Vn. So now we have our second equation, and also in terms of V naught, Vg, and Vn. So I'm just going to label this equation 2. So from the first slide, we got equation 1 from this first node, and this first node here, and then the second equation we got from the second node right here. So if we were to combine these two equations, or just make a simple substitution, I'm just going to start a new page now.